let's graph this rational function. The first thing we need to do is factor the numerator and denominator to see if any factors cancel out. If they do, that will indicate that there is a hole in the graph instead of an x-intercept or a vertical asymptote. So, looking at the numerator, let's see if this will factor. X squared is x times x. 8 is 2 times 4, or 1 times 8, but probably 2 times 4. Inner plus outer must equal the middle. Inner, I've got 2x. Outer, I've got 4x. If I'm going to get a positive 2, then I need a negative 2 and a positive 4. So that would be like this. That will give me the negative 8 that I want. Negative 2 times positive 4 is negative 8. So this is how you factor that. Now the denominator, the first step of factoring is to factor out the GCF, the greatest common factor. If I pull out a negative 4, if I want to see what's going to go on the inside, I would have to divide everything by negative 4. So that will give me x minus 3. Nothing cancels out, so that means there won't be any holes in the graph. So I will have x-intercepts and vertical asymptotes. So let's start with the intercepts. So x-intercept. As long as there aren't any extra numbers being added or subtracted on the end, you can find the x-intercepts by setting the numerator equal to 0. So if I did that, the next thing I would do is set these factors equal to 0. So I'd have x minus 2 equals 0, and I'd have x plus 4 equals 0. That would give me x equals 2 and x equals negative 4, which means I would have x-intercepts of 2, 0 and negative 4, 0. So let's go ahead and graph those x-intercepts. Okay, so I have one here at 2, 0, and I have another one at negative 4, 0. Alright, so those are my x-intercepts. How about y-intercepts? Okay, for the y-intercept, you can just put the function in your calculator. If you wanted to do it by hand, what you're doing is, you know the y-intercept is always going to be 0, something. In other words, the x value has to be 0. If I put in 0 for all the x's in the problem, that's going to make all these terms go away because they have zeros in them. So that would just leave this. Alright, it would leave negative 8 over 12. Both of these are divisible by 4, so that's negative 2 over 3. So that's going to be the y-intercept is 0, negative 2/3. Okay, now if that blew your mind and you were like, what is he talking about? Then you could always just put it in your calculator. So let's see. We have x squared plus 2x minus 8. And we have negative 4x plus 12. Alright, and I want the y-intercept, so I put in 0, and there's your negative 2/3, just like we said. So let's plot the y-intercept as well. Alright, so 0, negative 2/3 would be right about here. Okay, now let's talk about the vertical asymptote and the horizontal asymptote. Alright, so the vertical asymptote is what you get if you set the denominator equal to 0. Okay, You can ignore the constant because that can't equal 0, but setting x minus 3 equals 0 gives me x equals 3. So that is a vertical asymptote. Alright, so I'm going to have a vertical asymptote right here. What about horizontal asymptote? Alright, for the horizontal asymptote, that's all about degree. The degree of the numerator is 2 because of the x squared. The degree of the denominator is 1 because I just have plain x is the highest. So when the degree of the numerator is greater than the denominator, that's when there is no horizontal asymptote. On the other hand, if the degree is 1 more than the denominator, then there will be a slant asymptote. Okay, so we do need to figure out what the slant asymptote is, because there should be one. So the way you find the slant asymptote is by doing long division. So if I take my negative 4x plus 12 and I do my long division, alright, x squared plus 2x minus 8. Alright, so the first thing we have to do is divide. So I look at these first two terms, so I've got x squared divided by negative 4x. I need to divide this by that and see what I get. So this x is going to cancel out one of these x's. So that's going to leave me with x over negative 4. Or another way of writing that, because this is like having a 1, so this would be the same as negative 1/4 x. Negative 1/4 x. So I have negative 1/4 x. Okay. Now that is going to, then I'm supposed to multiply this and see what I get. So if I multiply this, remember, multiplying by 1/4 is the same thing as dividing by 4. So I'm going to get a positive 1 when I do this. Negative 4 times negative 1/4 is 1. X times x is x squared. Alright, a negative times a positive is a negative. 1/4 times 12 is 3, because 12 divided by 4. And then I'll have the x. Okay, then I will subtract by changing the sign. So this will be minus and this will be plus. These will cancel out, but this will make 5x. And then I will bring down the minus 8. So then I need to do that over again one more time. Alright, I need to keep going until the degree of this is less than this. So I see that they're both degree 1, so I have to keep going until this is degree 0. Alright, so I'm going to divide once again. So I'm going to divide 5x divided by negative 4x. So those x's will cancel out, and that will make negative 5/4. Okay, so I'm going to have negative 5/4 up here. Now I'm down to a constant, so I could keep going. I could multiply this and put it down, but whatever happens next is going to be the remainder. So I don't need that in order to do what I'm doing. So this is the slant asymptote right here. All right, negative 1/4 x minus 5/4. Okay, now 5/4, what is that as a decimal? All right, 1.25. Okay, so this would be pretty tough to graph. So here's what I'm going to do to graph this. I know this is just going to be a straight line. So I'm just going to graph the x and y intercept of this and connect the dots. Okay, so think about the x and y intercept of this line. So the x-intercept will have a y value of 0. The y-intercept will have an x value of 0. So let's see these 2 points. If I put in 0 for x, I'll come down here. If I put in 0 for x, then that is going to just be y equals negative 5/4. All right, because if I put in 0 for x, that's going to make this term go away and just leave the negative 5/4. So that, and we just found that that is 1.25. So this would be negative 1.25. Now, what if I put in 0 for y? What would x be? Okay, so if I put in 0 for y, then I would have, let's see, negative 1/4 x minus 5/4. I would have to add 5/4 on both sides, so that would give me 5/4 is equal to negative 1/4 x. Let's see, what is the easiest way to deal with this, man? I am going to divide both sides by negative 1/4 to get x by itself. Okay, so if I did 5/4, you know what, let me do it the other way. I'm doing 5/4 divided by negative 1/4. So if I do 5/4 divided by negative 1/4, that gives me negative 5. Okay, so this is the x and y intercept of this slant asymptote. So in other words, the slant asymptote should pass through negative 5, 0, all right, which is right here, and it should pass through 0, negative 1.25, all right, which is like right here. Yeah, okay, so I'm going to make sure my slant asymptote goes through those 2 points. Okay, so my slant asymptote should be looking something like that. So I have a vertical asymptote, and now I have this slant asymptote. Okay, so that's it for the asymptote. So let me get that out of there. All right, I know that was pretty complicated, but that's what you have to do sometimes. So now I just need a few extra points to see what is going on with the graph. So let me erase all this to make space. Every vertical asymptote gives you 4 points that you need to graph. In this case, we only had one vertical asymptote. So we're going to get those 4 points for sure. Our vertical asymptote, remember, was x equals 3. Okay, so if I put 3 on my number line, imagine going to the left and right of that. That would be 2 and 4. You know what, let me change those colors. Alright, because the pink numbers are the ones I'm going to be graphing. So I'd have 2 and 4. Now halfway in between, I would have 2.5 and 3.5. So these 4 pink values are the 4 values that I need. Now we already have the value of 2. So let's move on to 2.5. Alright, because 2 was our y-intercept. What was one of our x-intercepts. So let's move on to 2.5. Okay, at 2.5 we have 1.6. Okay, so 2.5, we're at 1.6, which is right about there. Okay, let's move on to 3.5. Alright, at 3.5, we're at negative 5.6. Alright, so 3.5 and down to negative 5.6 should be right about here. And one more, let's see where we are at 4. At 4, we're at negative 4. So 4 comma negative 4. Okay, so 4, negative 4. So we are right about here. Alright, so we're going to take these points, and this should be enough to show us what the graph is doing, together with this slant asymptote that we've got. Okay, so we're passing through these points, but we're approaching the slant asymptote and the vertical asymptote. So I'm going to pass through these points as I approach the asymptote on either end. And I'm going to do the same thing here. Okay, I have to approach the asymptotes and at the same time pass through these points. So it's going to look something like this. Now let's take a look and see what we got. Alright, clearly the answer is B. Okay, just take another look how B compares to this with the vertical asymptote at 3, and there's no horizontal asymptote, but you can see the slant asymptote happening there, just as we predicted. Okay, and that's it. So the answer is B.